This is part 2 for the Samsung PN43F4500 AF that was totally dead, and this one had the buffer board failure. So before I put the new buffer board in, this is the second buffer board, the first one was defective. We'll do a little bit of a recap on how I got there, and then we'll put the new board in and show you how it fixes it. Coming right up here on Tech Talk. Now, if we remember on this set, the set won't turn on. And what we're getting now, the client actually originally he bought a power supply board himself, and that's not the case. And as you notice, when we try to apply power, we'll see that the VS voltage comes up momentarily and goes off. And you'll also note that the health light is not blinking as it should. Under normal operation, the health light there will blink about once every second, but as you can see, it's only blinking about once every 5 seconds, which is telling us that the set is going into a protective shutdown. Most likely the buffer board on the left that you see, that's the Y buffer, Y sustain board. That is a combination board on this set, and that is going to be the likely issue. So let's change it. First, we have to disconnect the panel, and this is critical that this is done as carefully as possible, because if you tear these tab connectors, you've ruined the panel. So take your time. We're going to carefully remove the panel and disconnect all of the flat ribbon connectors to the panel, and then we're going to remove the board, and we're going to test it with an ohm meter and verify that it's shot, and then we'll go about replacing it with a new one. So to measure the buffer chips, we're going to put the meter in diode test mode. I'm going to put my negative test point on the out L, I believe it is, and we're going to measure all of the connectors. We're going to look for shorts. So we should see either open or like a 0.7 volt drop, depending on the polarity of the probes. But we'll typically see about a 0.7 volt drop in one direction and open in the other. But what we're going to do is we're going to look to see if we have any that are shorted.
That's normal. What we don't want to see is a short, right? Keep the probe on the L, and we can just drag along until we find, okay, that one's good. That's measuring these chips. Oh, 0.2. Okay, that's a problem, you see? We got to short this IC here. See that? Got a short on that IC.
So this quick, simple test will determine that you've got a bad buffer IC. And some may say, try changing the IC, but you know what? When you can get these boards as reasonable as they are, I would just replace the entire board on this and not mess around with trying to take out one of these FPICs, flat pack ICs, because these ones here are bonded down to the board, and they've got a silicon coating over them to protect them from any moisture ingress and so forth. So we test them all that way. We found we've got one shorted. Let's get the new one in.
Okay, the second replacement for that defective board is here. So here's the next replacement board. And yes, if you're wondering, this is a scalpel.
I still have to laugh at the packing. It's, real good static protection on this thing, I tell you. If you're wondering why I document the unboxing and unwrapping of parts, this is just to protect myself. So if someone tried to say, oh, you damaged it, you damaged the part, I sent you a good part, and it's my word against yours. So I always, when I order parts, especially if they come in off eBay, I always document the actual unpackaging of the product, so that if there's any argument as to, any funny business, if someone's trying to say that I'm
exceptionally sharp,
trying to pull a fast one, well, I've got the video evidence that it comes out of the bag and it gets tested in one shot without the camera stopping.
So here's the replacement board. And like before, we'll test all the connectors for any shorts. We'll put the meter in diode test mode. And we'll just test each of these connectors, each of these pins.
Okay, now this board actually tests good, so there's no point in me showing the procedure to test them all because we've gone through this before. But basically, I'm going to test every pin on each of the connectors, both with the negative on the...
And I can see any voltage drop across this. We're not making a good connection here.
So I'll test it with the negative probe on the out L and the out H, and then reverse the probes and put the positive probe on there and run the negative across them. What I'm doing is I'm looking for any shorts, and if I don't see any shorts, then I don't have an issue with one of the buffers being bad, and I can put the board in knowing that there's nothing seriously wrong with it. So now we'll reverse the polarity, and now we will see the 0.8 volt or 0.7 volt drop because we're measuring.
Remember, what we don't want is we don't want to see a short.
We're measuring the junction.
These pins.
So this board tests good. Let's get it in the set.
Insert the edge connectors for the panel. Make sure that you get the tab all the way in, and then flip down the gate. Next is the signal cable and the power connector. And finally, we'll apply power to the set and see if it fixes it. Okay, the moment of truth. Got my power cord. Almost nervous to plug this thing in. No, I'm pretty confident that we're going to fix it. Power. Okay, good sign. Okay, our heartbeat's going about 1 pulse per second. You know what that means, right? That means no faults have been detected. Let's turn this thing around and see if we get a picture off of it. What do you think? You think it's fixed? Let's see if we can switch inputs on this thing here. Functions available. Where's my source? Might be that one. HDMI. I've got it plugged into my Blu-ray player. Hey, look at that. Beauty, beauty. It's fixed. That's it. That's all that's wrong with this one. Was that buffer board. Okay, here's some of my own stuff that I can show. Looks great. Looks like the picture's a little bit small. Have to adjust the size on that. That's just the scaling of this. This picture is small, but it's not a fault of the TV. This particular program is not quite, it will not quite fill the screen fully. It's just the way I've got the media player set to play it. So it does show up like that. That's normal for this particular program because this was shot in 4K. And the 4K picture size, when it's played back at standard definition resolution, actually this was rendered out as an HD stream, but it's being played back in standard definition over an analog channel. It doesn't scale exactly to the the channel. Okay, if I go to an active channel, these are just analog channels. You see that fills the full screen. This should fill the full screen too. If this is a, no, this is not a full screen. I'm just going through my house cables here, my house cable channels. Anyway, it's working. Go to HDMI. There we go. That's coming off the Blu-ray player. It's fixed, so there you go. Now it's time to put this one back together. Okay, there it is. It's back together, ready to go. So remember, if you got one of these Samsungs, check the heartbeat indicator. If it's not flashing at about 1 hertz, chances are it's going to be one of the boards. Quick and dirty way to test the driver, the buffer boards, is just to measure between your out L and out H test points. Measure, put your negative probe on, measure all the connections, looking for any shorts, and then put the positive probe on, do the same thing, and do the same thing with the out H. Should have no dead shorts between any of these pins. Any dead shorts on here means one of these ICs is cooked. It's time for a new board. Hope you enjoyed this video. We'll catch you again in the next one real soon. Bye for now.